Hello everyone, this is Nico here with a quick test to demonstrate the noise generated by Acasom versus noise generated by Raygnal. I'm going to run 3 different tests. The first test, I am going to connect each amplifier to a AirSpy Mini, and with the antenna point, I do have a dummy load, and same on the Raygnal side. Now, I want to compare the noise we receive from an antenna with cavity and dummy load. Let's see if there are any differences in numbers. This will give us a clear indication of which amp generates more noise. Currently, Acasom is connected to AirSpy. Now let's turn on the SDR. Now for this testing, I'm going to use the AirSpy gain around 14 dB, so that we do not kind of change the testing methodology for different tests. Now, using no antenna, no cavity, and just dummy load, we get around, and without the amplifier being powered, we get around 98.6 to 98.8. Now, this is just the amplifier being the AirSpy amplifier generates this noise itself, which is our baseline. Now, what we'll do is enable the BISD from the SDR, and you can see that our noise floor has gone up. Previously it was minus 98.6. Now we have a figure of minus 97.2. Now, obviously this is expected. Apologies. Now, what we'll do is I will run the exact same test on Raygnal to see if we get this similar noise level. Now, if we look at the noise floor, we are getting pretty much exactly the same. The difference is 0.1 at this amplification, which is 14 dB for AirSpy. Both Acasom and Raygnal, the RX is set to 10 dB. Let's record 97.1 for Acasom. Sorry, Raygnal. Now let's run this test again, but instead of using demo load, let's test with an indoor antenna attached directly to the cavity filter. From the cavity filter, we will connect to the amplifier. Let's see if and what noise we're going to get. Didn't need to do that. this right now. Let's get in the view so that you see clearly. AirSpy Mini connected to Raygnal, Raygnal connected to the cavity filter, and we have a small indoor antenna that came with Panther X, which I believe is around 3 decibel. Now let's turn on the SDR. Let's just fix the connections. There we go. Now we are getting some beacons through, which is great. We can see that the antenna is working and we are getting some signal. Now, if we look at the noise floor, we are getting around minus 85.0, 0.3, 0.5, 0.5. Now, let's run the exact same setup with Acasom. And let's see what we get. Okay. Now that the Acasom is powered, connected directly AirSpy connected to Acasom then connected to the cavity filter, and we have the same, oh, that's the interference from a microphone, the same antenna. Now, let's double check the connections so that I don't want to be biased. Now, this is Acasom connected to the antenna with cavity filter. Now, we are getting some signals through. However, if you look at the noise floor, it's around minus 80.8. 7.5 minus 80.5. Now, compared to the Raygnal just before, this is around 4 decibel places. Now, this shows that Raygnal is performing much better at reducing noise. Now, just to double check, I'm going to reconnect Acasom just so that I have not made a small mistake. Let's turn off the bias T. Connections are secured. Okay, we are securely connected. Let's rerun this test and to see if the numbers we had previously were correct. Now, the bias T is off. We have the baseline minus 98.6 to 98.8, which is what we had before. That's enabled bias T. Now, the results pretty identical to the previous version. Acam performing around minus 80.0 to minus 79.9. We are getting a lot more interference with Acam versus Raygnal. We are still getting some signals through, but not as quality as before. Now, I'm wondering if we can improve the signal. Yeah, that's the interference from the microphone. Let's push it further. Yes, so we can confirm that Acam is creating extra noise compared to Raygnal. Now, I'm going to run this test again. This time, going to remove the cavity filter and connect directly to the antennas. And let's see if we're going to get any better or worse results. Let's turn off the bias T. Now we connected directly to Acam to AirMini. Let's turn on SDR, enable bias T. You can see that our waterfall got more saturated without cavity. Now, previously Acam was around minus 80.8 to minus 81 point something like that, and now without the cavity is around minus 77.9 to 77.2. Now, we always suspected and knew that Acam always required a cavity filter in order to run, to reduce the noise it generates. And let's compare this with Raygnal without cavity and see what results we get. Now we are connected directly to Raygnal, no cavity, straight to AirSpy. Now let's turn on our SDR. Our noise floor is same without the bias T being enabled, which means the amp is off. And then let's compare. And this is Raygnal without cavity, connected directly to the antenna. Now we are getting around minus 82.2, 85. Nope, sorry, 82.5. Now, looking at these, which on this, Raygnal performs better than Acam together with cavity filter. Now that is not surprising considering Raygnal has 4 SAW filters inside, which means that it definitely helps to reduce the noise. Now what's surprising is that how much better Raygnal does compared to Acam. Now I will publish the numbers in the description. Just to recap, no antenna and cavity, directly connected to AirSpy to amplify and using a dummy load. Acam, the noise floor was around minus 97.2 versus Raygnal minus 97.1 or 2, which pretty identical. Now this is using dummy load, which would have been expected. So there is no extra noise being created by the amps itself. Now the results are totally different when I connected an indoor antenna. Now the second test I run was antenna, cavity filter, amplifier, then to AirSpy. Now Acam gave a figure around minus 80.8 or 2 minus 80.5. Now if you compare that to the Raygnal, which was around minus 85 to minus 85.5, which is around 5 decibel lower than Acam, which is quite surprising. To an extent. What was even more surprising is that Raygnal performed better or identical to Acam with cavity filter. Now, Acam connected directly to antenna, the noise floor was around minus 77.9 to 78.2. Now, comparing that to Raygnal, which was around minus 82.2 to minus 82.5. Now, if you remember, Acam with cavity and antenna was around minus 80.8, which is around 2 decibel worse than Raygnal on its own. Now, obviously there's a clear winner. The beauty of Raygnal is not just that it generates less noise or performs better without cavity, which is a bonus, which is quite similar to jet vision, where it doesn't need a cavity depending on your area. Now, what Raygnal also offers, if you guys can see it, is that you can ask for any particular gain you want on your RX and TX, and you can use the dip switches inside to attenuate the signal, which means that you can request a RX 20 and TX 10, and you can adjust it for according to your needs, which gives you flexibility. Now, this version I'm using is RX 19 and TX 7, I believe. Now, I have attenuated, cannot pronounce that word, so that this was identical to Acasom in terms of gain. So both of these were 10 dB RX amplifiers. Now, this was a quick test. Lasted longer than I expected. However, if you have any questions or suggestions in terms of my testing methodology, please let me know. I am currently testing a setup without amplification and using a splitter to gather data, and I will be attaching this Raygnal amp to see what difference it makes to that setup. But for me, clear winner is Raygnal, and hopefully in the next couple of days I will be testing against Aptronics. Someone from the Discord is kindly sending me one, and yeah, I will share those results as soon as they're ready. Thank you for watching.